Good morning students. So in this class we are going to discuss about vector product of two vectors. So vector product of two vectors is defined as another vector having a magnitude equal to the product of magnitudes of two vectors and sine of the angle between them. So it's another vector product of magnitude of two vectors and sine of the angle between them. So that is C vector equal to A cross B. So A cross B equal to AB sin theta n cap. So n cap is a unit vector pointing the direction of the vector. So that A vector and B vector are in the plane, that is A and B. The resultant vector is perpendicular to the both A vector and B vector in the plane. So if it is A cross B, if it is B cross A, so B cross A equal to minus C. So the direction of C vector in downward direction, so it's minus C. So A cross B equal to, A cross B is not equal to minus, that is B cross A, so that is not commutative. So what are the properties of vector product of two vectors? So the vector product of two vectors is always another vector. So A cross B equal to another vector C vector. So that is vector product of two vectors is always another vector. Then A cross B is not equal to B cross A because A cross B equal to minus B cross A. So if it is B cross A means, so the C vector is reverse. Then so A cross B, so the product of cross product, that is A cross B, is maximum when theta equal to 90 degree. So the angle between A vector and B vector is 90 degree. So that A cross B equal to AB sin theta. So sin 90 is equal to 1. Then A cross B is minimum when the angle, that is A vector and B vector in the same direction, or A vector and B vector in opposite direction, the angle is 0 or 180 degree. So A cross B equal to 0. Then A cross A equal to, that is self cross product. So A cross A equal to AA sin, so the angle is 0, so sin 0 0. So the self cross product of two vectors is 0. So in similar manner, self cross product of that unit vectors, so I cross I, J cross J, K cross K is equal to 0 because sin 0 0. Then I cross J, so I, J, K are mutually perpendicular, that is orthogonal vectors. So I cross J, so I vector and J vector are 90 degrees, so angle between them is 9. So in 90 you will get, so I cross J, so the product of two vectors is always another vector. So I cross J is a K. Then J cross K is I, then K cross I is J. So it's a cycle, that is circle. So in anticlockwise, so I cross J is K, K cross I is J. It's like that. So I cross J, J cross K, K cross I. So the next term will be the answer. If it is reverse, J cross I equal to minus K, I cross K equal to minus J. So because A cross B is not equal to B cross A, because it's not commutative. So I cross J is equal to K, J cross K is equal to minus I. The next, A cross B in terms of, so A vector and B vector represented by X, Y and Z, that is Cartesian coordinate system. So it's AX, AY, AZ. So A cross B equal to I, J, K, that's a 3 cross 3 matrix. So the result I into AY, BZ minus BY, AZ, then plus J into, so next J, so AX, BZ, AX, BZ minus, then AZ, BX. So if you put it minus here, so AX, BX, BZ minus AZ, B, so like that. If you break like that, so you have a 2 cross 2. So it's I means AY, BZ, BY, AZ, then 9, then J, AX, BZ, BX, AZ, then K, AX, BY, AY, BX, that's all. It goes on, so plus K into, so AX, BY minus BX, AY. But here plus minus plus, if you put it plus here, you need to reverse and minus. So that's all. Then A cross B equal to AB sin theta. If A vector and B vector are are the two adjacent sides of a parallelogram, then area of a parallelogram is the A cross B. So A cross B equal to AB sin theta. Here A vector and B vector are the adjacent sides of a parallelogram. Then area of a parallelogram is A cross B. So that is A cross B. So we can divide the parallelogram into two by cut it half. So this is a triangle. So A cross B by 2 is equal to area of a triangle. So just divide the parallelogram into 2, will get area of a triangle, that is A cross B by 2 equal to area of a triangle. In some other physical examples, tau is equal to R cross F. So tau is a vector, R is a vector, F is a vector. Then L equal to R cross B. So R is a position vector. So here tau is a torque, then position vector force. So the product of two vectors is always another vector. So the angle between R and F is 90 degree means then tau is also 90 degree. They both are mutually perpendicular to each other. So L equal to R cross P. So it is angular momentum, here linear momentum. So in this class we have discussed vector product of two vectors, that is A cross B equal to AB sin theta, then properties. So it's not commutative. Then A cross B is maximum when theta equal to 90 degree, minimum theta equal to 0 or 180 degree. So self cross product is 0, then I cross j equal to k, like that in anti-clockwise direction. Then A cross B equal to 3 cross 3, then is I j k, ax ay az, bx by bz. Then A cross B is if A vector and B vector are the two adjacent sides of a parallelogram, then area of a parallelogram is A cross B. If it is cut into two, that is triangle, so area of a triangle equal to A cross B by 2. So that is like that. So A vector is B vector. If you connect, this is a triangle. So area of a triangle equal to A cross B by 2.